How do we know that the square root of 2 is irrational? There are a couple proofs for this, but this one's my favorite. We are going to do a proof by contradiction. There are only two scenarios. Square root of 2 is rational, square root of 2 is irrational. We're going to look at the case that the square root of 2 is rational, and we're going to see that things fall apart, meaning the other scenario has to be true. So let's assume that the square root of 2 is rational, meaning it can be written as a simplified fraction a over b. Now, we're assuming that a and b are positive integers, and they have no factor in common besides 1. Now, when we square both sides and multiply both sides by b squared, we get 2b squared equals a squared. Now, let's talk about square numbers. Square numbers have this property where each of its prime factors is raised to an even exponent. That's the only way we can write an integer squared. Now, 0 is even, and 0 is fine as an exponent because a non-zero raised to the 0 is 1. That is not going to affect this. And here are a couple examples. And take note that we can include prime factors raised to the 0. Now, let's take a look at this. A squared and b squared are both square numbers, meaning they both have an even number of factors of 2. I don't know how many factors of 2 they have, it could be 0, but I know that they both have an even number of factors of 2. Now, b squared is being multiplied by 2, so 2b squared has an odd number of factors of 2, whereas a squared has an even number of factors of 2. Wait, this seems impossible. These will never equal each other, because there's no number that has an odd number of factors of 2 and an even number of factors of 2. So there's our contradiction. So when we assume that the square root of 2 is rational, things fall apart, meaning the other scenario is true, that the square root of 2 is irrational.